Now, it's thought resistance to antibiotics is linked to the deaths of 5 million people worldwide every year. That's according to the World Health Organization. And some bacterial infections are getting tougher and tougher to treat with the drugs currently in use. But there is a glimmer of hope. Scientists in the US say they've discovered a new class of antibiotic that acts in a new way to target one of the 3 bacteria posing the greatest threat to human health because of their resistance. It is now being tested in human trials, but doctors say they are a very long way from being able to use the new antibiotic compound, but they are extremely hopeful. Well, let's get more on this and bring in Dr. Bharat Pankhania, a senior clinical lecturer at University of Exeter's Medical School. Bharat, thank you very much indeed for joining us. Great to have you back on the News Hour and great to have a positive news story to talk to you about. So just tell us how significant this is and what sort of illnesses it may be able to treat.
So it is a great development in that we haven't had a new antibiotic against what we call gram-negative bacteria for almost 50 years. And the way this antibiotic works is that it prevents the transport of what we call lipids, lipopolysaccharides. So these are lipids that form the inner and outer membrane of this specific type of bacteria. And what this antibiotic does is it interrupts with the transport mechanism. Having said that, it is very bacterial specific. In other words, it is not an antibiotic for many other bacterial infections. It is a potential antibiotic for specific types of bacteria, which are often found in hospital settings, Acinetobacter baumannii. Now, these bacteria are often cause of sepsis and pneumonias and persistent infections in clinical settings like hospitals.
Right, and those bacterium that this may be able to treat, have those become completely resistant to any of the other antibiotics that are on the market?
They have not become absolutely resistant, but there is a growing trend towards resistance and difficulty. So what we call CARB, which is carbapenem-resistant bacteria, meaning carbapenem being the name of an antibiotic. And when you can't use that antibiotic, we say, goodness me, we've run out of antibiotics. So in that case, for this specific bacteria, there's some ray of hope. Remember, at the moment, it's only clinical in the laboratory, treated with upon mice and in the Petri dish. We will need to do human trials to see its safety profile and to see how it performs in actual clinical settings.
Right, and so if we're at this stage, it's been tested on mice, human trials are to come. Let's say all that goes well. How long before it's out there on the market?
It's difficult to say, but this is the one big step forward because this is the step that takes the longest time. And thereafter, human trials, etc., take a lot shorter trial because all you've got to do is find the right patients, administer it in a low dose and watch how it performs and see how its safety profile is. So it's not long if it works in a clinical setting with humans.
Right, well, that is positive news. Finally, Bharat, I mean, how have we got to this point, this point where we are desperate for new antibiotics to treat those infections and illnesses? Is it simply because of overuse and doctors handing out too many?
So that's a very great question. It is a multifactorial thing. One, pharmaceutical companies find it's not profitable to invest in antibiotic research. The second bit is injudicious, in other words, using it willy-nilly for all sorts of infections. The third thing is natural evolution, which is bacteria by its very nature, they mutate, and therefore any antibiotic, even this new one, always has a time limit. It will never be an antibiotic forever. This is evolution in progress. And finally, one other thing we must never forget, which is feeding antibiotics to animals to produce food, that also leads to the emergence of resistant strains. Feeding antibiotics to farm animals to make food.
Partially human fault then, but thank goodness there are scientists developing these sorts of things to give us a ray of hope for the future. Bharat, we thank you very much for joining us, as always. Dr. Bharat Pankhania there.
Thank you.